Hi, everybody. We are now in week 3 of our remote learning. What we're going to be talking about this week is solving exponential equations. So let's go ahead and get right to that. Okay, so exponential equations, first thing I want to do here is give you the definition and then do a couple examples here for you. So the definition, if you've been following along the last couple of weeks, almost should be familiar. The definition, just like exponential functions, exponential equations have the variable in the exponent spot. Just like this example right up here in the corner, 5 to the x. X is our variable, it's in the exponent spot. Just want to remind everybody that other number that's not in the exponent spot, that's called our base. It has a name too, and it's our base, okay? And that's going to be something that's very important as we do these examples. The key to solving is that the base on the left and the base on the right must be the same. So every time you start one of these problems, the first thing we should be paying attention to is the base, because they're not going to be the same, but we got to make them the same, and then we can take the next step and get to the end. So let's go ahead and do an example. We're going to solve this equation right here. We've got 4, and then in the exponent spot, 3x minus 11 equals 16, and that's got 4x plus 2 in the exponent spot. So, maybe some of us recognize, hopefully we do, maybe we don't, but that's okay, that 16 is 4 squared. And that is not a coincidence, because we need these bases to be the same. This base is 4, this base is 16. Right now they are not the same, but we do need them to be the same to get through this problem. Well, okay, so if 16 is 4 squared, we know that because 4 times 4 is 16, so 4 squared is 16. We can change this 16 into a 4 squared, and that's exactly what we're going to do. Everything else stays the same. This 16 just changed into a 4 squared, because 4 times 4 is 16. Now, I want you to make sure we're paying attention here. I put this 4 squared inside parentheses right here. And I absolutely did that on purpose, because what we're going to have to do is distribute this 2. This is an exponent with another exponent on top of it. So we got to distribute this 2 to the 4x and then to the plus 2 at the end. So let's go ahead and do that. So 2 times 4x is where the 8x comes from. And then distribute 2 to the plus 2. 2 times 2 is 4. That's where the plus 4 comes from. Notice now that our bases are the same. This base is 4 and this base is 4. That's exactly what we want. There's no 16 anymore. We got rid of that. We kind of just wrote things differently so that we had a 4 there instead of a 16. And so now that our bases are the same, we can essentially just ignore them. They're the same, so why even bother with those? So we're just going to bring down the 3x minus 11, just the exponent, just ixnay the 4, and also bring down just this 8x plus 4 over here. Okay, just get rid of that base. Now we just took one exponent equals the other exponent. Okay, so now we're going to go ahead and solve this equation. We've got x's on both sides. That's not good. We can't solve an equation if x is in more than one spot. So what I like to do is I like to pick whichever one is the smaller one or the least one. I like to pick on that one. I'm not a fan of bullying when it comes to human beings, but when it comes to math, I like to pick on the little guy, because then it always makes our other x positive. We'll always end up with a positive x if we do that. So I'm going to pick on this 3x because he's smaller than the 8x, and we're going to take away 3x. But if we take away 3x, we got to do that on both sides, right? So 8, take away 3. Now we're only left with 5x. Everything else stayed the same. We just took away 3x from both sides. Okay, now we've got negative 11 equals 5x plus 4. Now what's the next step to getting x by itself right here? We need to undo plus 4. To undo plus 4, we minus 4. So take away 4, minus 4. Negative 11 minus 4 on this side gets negative 15. Now we're almost there. Last step, we just got to get rid of this 5. Undo times 5. So to get rid of that 5, divide it out. So negative 15 is negative 3. So x equals negative 3. Okay? That's all there is to these problems, really. Example 2, we're going to have an inequality this time. It really does not change how we do these problems very much at all. you're just putting a different symbol instead of an equal sign for the most part. And so let's just see how that works out. So the first thing we notice here, well, here we got 3. We don't have 3 on the other side, but what's 3 squared? 3 squared is 9. That's not what I have over there either. So it's not quite the same problem as the one we did over here. Okay, so, but what do we need? We need a 3. So how many 3's do we need to get to 81? And we're going to be multiplying here. How many 3's do we have to multiply to make an 81? Okay, well, if we multiply 3 3's, 3 times 3 times 3 times 3, so 4 3's here we're going to multiply, and that makes 81. If you don't believe me, put it in your calculator. I'm telling you, 3 times 3 times 3 times 3 is 81. Okay, so it took 4 3's to do that. We cannot use any other number. We have to use 3's because that's what's on the other side, and we have to multiply them. So if you're trying to figure out what should go over here, take this base and just start multiplying them and figure out how many you need. How many do you need to multiply together to make the big number on the other side? This time it took 4 3's to make an 81. 3 times 3 times 3 times 3. Okay, so we're going to take that 81 and we're going to change it to a 3 to the 4th. 3 because that's what we multiplied, and the 4 is in the exponent spot because that's how many 3's we needed. Okay, that's how many 3's we needed. So just like now we're just doing a problem just like the one we just did. This 4, we're going to have to distribute that. 4 times 4x, 4 times the negative 2. So that gets us negative 16x minus 8 in the exponent spot. And our base is 3 on both sides, just like we want. We have the same base on both sides. That was the goal, because now we can just get rid of them now that they're the same and use just the exponents. So now we've got 3x plus 18 is greater than 16x minus 8. So now I'm going to do the same thing I did over here. I'm going to pick on the little guy, 3x. He's smaller than 16x, so I'm going to take away 3x from both sides. That's the same thing. Take away 3x from both sides. 16 minus 3x is 13x. I'm trying to get that x by itself, so we got to add 8 to both sides. What do we get? We get 26. 18 plus 8 is 26. Got to add 8 to both sides. 26 is greater than 13x. And the very last step here, we got to divide by 13 to get x by itself. Divide by 13. So 26 divided by 13 is 2. So our answer, 2 has to be greater. X has to be less than 2. Or 2 has to be greater than x. Okay, the one thing I did want to remind everybody about that is tricky with inequalities sometimes is that if you multiply or divide by a negative, then you must switch the sign. It says that down there at the bottom. For inequalities, if you multiply or divide by a negative, then you must switch the sign. Just make it open the other way. That's all you got to do. All right, one more quick example, because this one, it's not quite like the other ones where you just figure out, okay, well, 25. How many 25s do I need for 125? Okay, and you can add up 25s to 125, but remember, we have to be multiplying. Okay, so even if I just use 2 of them, 25 times 25 is 625. That's not the right number. I don't want 625. It's got to be 125. So I can't use 25s to make a 125. That's not going to work. But what can happen? Well, I can make 125 out of 5s. 5 times 5 times 5, 3 of them. That multiply 3 of them, and you get 125. And I can make 25 out of 5s, just 2 of them. 5 times 5, multiply that, and you get 25. So I can use 5s to make 25 and 125. So this is an example where if the small number does not go right into if the small base does not go right into the big base, that means you got to change both of them. You got to find a number that goes into both. In this problem, that's 5. 5 goes into both. 2 5s is 25, so we get a 5 squared here. It takes 3 5s. You got to multiply 3 5s to get 125, so we got 5 to the 3rd on the right side. Okay, so just like before, they're both in parentheses. So actually what we have to do here is we have to distribute on both sides. 2 times 2x and 2 times plus 5. You get 4x plus 10. And on the other side, 3 times 4x is 12x. 3 times 14 is 42. Okay, so what do we got? Oh, we got a base. Our base on the left is 5, and our base on the right side is 5. Okay, so that's exactly what we needed to happen to keep going with this problem. All right, so now we can just get rid of the bases and just put 4x plus 10, the exponent on the left side, equals 12x plus 42. That's the exponent on the right side. And we can just finish this problem just like the first two. Okay, we're going to pick on the little guy, 4x, take away 4x from both sides. So 12 minus 4x is 8x. And then we're trying to get x by itself. So we have to subtract 42 away. So 10 minus 42 is 32. And the last step, we have 8x. We got to divide by 8 to get x by itself. Negative 32 divided by 8 is negative 4. So x is equal to negative 4. And that is your answer. Okay, the other thing we need to talk about in this one is called compound interest. This is important because this is how interest actually works for loans or credit cards. So the last time you watched a video, we did talk about a second way to write exponential functions and equations, and it looked like this. And I was going to run back over this really quickly. I'm not going to spend a whole lot of time on it because I already went through this with a lot of time in the last one. Okay, so this g of t equals a, and then in parentheses 1 plus r, and the parentheses have an exponent of t. And what we talked about last time is a is the amount of money that you start your savings account with, or just your starting value in general. T stands for time. It could be measured in days, weeks, months, years, or other unit of time. And then R is the growth or decay rate. So R is your growth rate, T is time, and A is how much money you start with. And this will tell you how much money there is, in 1 year or 2 years or 3 years or 4 years, whatever. Okay? So compound interest is very similar to this equation that we just talked about. This actually has its own name. It's called simple interest. This one right here is simple interest. The compound interest equation does look similar. We still start with an A, and then we have a parenthesis, and then we have a 1 plus something, and then we still have an R, but it's a little bit different. Instead of just R, now we have R divided by N. And then in the exponent spot, it's almost the same. We still have a T, but now we have not just a T by itself, now we have N times T. Okay, so all the letters that are in the first equation mean exactly the same thing in the second equation. A is still your starting value, or how much money you start your savings account with. R is still your growth rate. T still stands for time. Okay, now the one thing that's really important to know right off the bat is that in the real world, especially for this bottom one, T is usually measured in years, and R is a yearly interest rate. Like when you go look for a car, they'll say something like 7% APR. APR stands for annual percentage rate. Okay, so annual, that's a year. So it's a yearly interest rate anytime you go for like a mortgage or car loan, or the interest rate that a credit card will advertise for you on an ad in your junk mail, all of that stuff. It's all based on it yearly. Okay, both the time and the rate, the T and the R are based on years. Okay, but interest is not just done once a year. Interest is usually applied more than once a year, and that's where the N part comes in. N tells you how many times in the year interest is applied. Most things like car loans and mortgages and credit card stuff, most of those things are compounded monthly. So once a month, there's 12 months in a year. So that would mean N is 12. There are other options like bi-monthly, which means you're only paying every other month. So then N would just be 6. Or there's weekly. There's 52 weeks in a year. So that would, if it's weekly, then N is going to be 52. Or you could do bi-weekly, every other week, and then N would be 26. Okay, so we'll do an example about this over one of these really quick. It's really not too bad. So a savings account has an annual interest rate of 3.6% and is compounded bi-monthly. If the account starts with $1,000, then how much money will be in the account after 3 years? So all I did right here was just take the equation from the last slide, the compound interest equation, and just copy it. That's all I did. That's just the equation that we just talked about. Okay, so A, that's how much money we start with. That's $1,000. We start with $1,000, so $1,000 goes in the A spot. Okay, and now let's talk about the R. So the R our rate is 3.6%. But if you remember in the last video, I made a point about this with a couple extra problems on our homework too about how to change a percent to a decimal number. You just got to divide by 100. If you do 3.6 divided by 100, then you get 0.036. So all I did was divide by 100 because I have to change the percent into a decimal. Okay. Where's the 6 come from in the bottom? Well, that 6 is in the end spot. And where'd that 6 come from? Well, they said that it's compounded bi-monthly. And if you go back to the last slide, if it's compounded bi-monthly, then you're paying then interest is happening every other month. And so it happens 6 times in a year. Bi-monthly, that means N is 6. And that was on the last slide. That's where the 6 up here in the exponent spot comes from too. It's the same 6. N is here twice. You put it in the bottom of the fraction, and you also put it in the exponent spot. And where's the 3 come from? Well, they said 3 years. T is time. They said 3 years. So we put T in the exponent spot. So the next step that I'm going to do is just kind of clean things up a little bit. I'm going to do 1 plus 0.036 over 6. And when you do 1 plus 0.036 divided by 6, you get 1.006. And then in the 18, that just is 6 times 3. 6 times 3 is 18. So did 6 times 3 where the exponent is, and then on the inside of the parentheses, I did 1 plus 0.036 divided by 6 to get 1.006. Okay, now the next step I'm going to do, because calculators are pretty good at doing this kind of stuff for you if you do it in small enough steps, do this step first, and now we just need to do 1,000 times 1.006 to the 18. And when you do that, you get $1,113.69. So one thing you want to make sure you're doing, I think hopefully I said this on the last video, I think I did, is the first video actually, is you want to make sure that you're trying these things on a calculator just to make sure that you're understanding how to use your calculator properly, whether it be on your phone or if you've got an actual calculator, or you can just Google calculator and a calculator will come up for you. But just make sure at the end of the day, if I can see that you're plugging things in correctly on our test on this stuff, you might lose a point because you don't get the right answer, but still, you don't want to be losing those points just because you made a mistake putting things in your calculator, right? You know what you're doing. Don't lose that point. So, okay, and that's actually where we end for today. That's it. So just like the last couple times, there's some follow-up questions for you to do and go formative. The link and code will be up there as always. So good luck with this homework, and as always as well, make sure you email me if you have questions. Please don't hesitate to email me. Make sure you use my nChristopher@plano88.org email to get a hold of me, okay? And I'll get back to you and help you out. All right, everybody, take care.